Hello, good people. I hope you're good wherever you are. Welcome again to this session. Today I'm going to record a short video speaking about the distribution bus in Slabs. This is a question I've received a number of times. People are asking me what exactly a distribution bus. Why do we need them? So I'm here to clear your doubts, right? So that next time you won't be intimidated if you hear the term distribution bus. Let me just go to my sketches very fast. I can do a sketch so that I explain what exactly distribution bus are. So assume you have a slab. Let's just say we have a one-way slab. This is our slab here, and of course, for us to maybe, let's say it is supported at this point, we have a beam here, have a beam running here, we also have a beam running here, right? That means that this slab will distribute its load to this beam and also to this beam, because it is a one-way slab, right? Well, if you want to know what a one-way slab is or a two-way slab is, I did a video on that. You can just go to my channel and you can just look at the videos there, search one-way and two-way slabs. You'll just find my video there. If you want to distribute this load to this beam and to this beam, that means our main bus should be running in this direction, right? Actually, the main bus are usually running in the shorter direction, so it is running from here to here. These are the main bus. These are the main bus running here. Then let me just erase this part here and also this part protruding. So those are the main ones, right? There's enough to distribute, to take this load. Saying we don't we just consider the distribution of that load, the transfer of that load to the beams, then this looks to be enough, right? But now why do we really bring in distribution bars again? Well, distribution bars are the ones running in the longer direction, right? I am sure you know that. So assume you have some load, maybe it's a concentrated load which is acting at this point here. You have a load which is acting at this point of the slab, right? In short, that load will only be carried by this bar here. That is true, right? It will only be distributed by this bar to this point and also to this point. If this load is acting just here, it is a concentrated load, and we do not have the distribution bars. Well, that means, let me just tell you how that looks like. This is the bar. I've just drawn this bar here. Then we have this concentrated load acting here, right? So instead of this load being distributed to these other bars, this load will only stress this bar, right? That means this bar will seriously be under stress, something of the sort, so that it will bend so heavily that the deflection here will not be allowable, right? So that means we have to find a way of distributing this load to these other bars, so that this load can be taken not only by this bar but by all these bars which makes up the slab, right? That brings in the idea of distribution bars. What exactly are distribution bars? Now, distribution bars are these bars running the longer direction. They're usually placed on top of the main bars, right? So they run in this direction here. They run in this direction. So let's take this scenario again. Let me just draw a 3D. So you have your slab, you have your slab here, right? And these are the main bus. All right, these are the main bus, and the distribution bus. These are the distribution bus. These ones here. Now take a scenario where you have your concentrated load is now resting somewhere here on the slab, right? So this is the concentrated load, right? So this concentrated load, right, will now be taken by this bar. I think this bar here, and what this bar will do is to distribute this load to this bar here, because this bar is running on top of this, it is running on top of this, and it is also running on top of this. So this bar here, this main bar here, is acting as a support to this bar. This main bar here is also acting as a support to this bar, and if there's a beam here, I mean, if there is maybe a main bar here again, that will also act as a support to this bar, right? That means this bar will be distributing this load here to this bar, and to this bar. Hence the name distribution bars, right? So basically it will distribute that load to the main bus, so that main bus will now take that load to the supports. So this main bar, after this distribution bar takes that load here, here, and here, the main bar will basically take it to the supports, where we require it to go, right? So that means in this case now, this bar will not be stressed alone, right? Rather, this load will be distributed to these other bars, to this bar, which will help carry that load. That is where a distribution bus comes in. Yeah, so if you have, maybe let me just draw this. This is the distribution bar, this is the main bar, and we have the load here. We have the load here. Then this bar will not deflect so much. It will be the deflection will be simply, the reliable one, right? Yeah, because we have distribution bars which are taking this load to the other main bus, right? So basically that is the point. I hope you will never be intimidated again with the term distribution bus, right, and main bus. So the point which you should be noting is that your main bus are running in the neutral direction, or rather they are running towards the supports, So if this is, if you have only supports here, here, and here, then your main bus should be running in this direction to the supports. Well, assume you didn't have a support here. So if this is the slab, and right now we don't have supports here, but we have support here, we have a support here, right? That means your main bus should be running in this direction. Okay, your main bus should be running in this direction, right? Yeah, and distribution bus should be running in this direction. So check very well where your supports are, where you want to distribute that load, so that you can tell the direction where your bus should be running. Well, something maybe I should also touch is how do we determine the sizes of both the main bus and the distribution bus? Well, you can determine the size of the main bus from the moments you have, so that you calculate the area of steel based on the moment which is acting there. So you have to do the analysis, determine the span moments and the support moments, so that you can determine the area of steel. Well, for one-way spanning slabs, main bus, you calculate the area of steel for that, but then for distribution bus you just get the minimum. That will depend with the code book you're referring to. So for BS 8110 part 1, it describes the minimum area of steel required for that to be 0.13% times breadth times the height of the slab, times the depth of the slab. h times b times 0.13%, right? So with that you'll have the size of the distribution bus. For two-way slab, if you speak of two-way, you have to design both the distribution bus and the main bus because they carry different moments, right? Yeah, so basically that is it. If there is any question, I'd really appreciate that because I want to interact with you as much as possible. Kindly just drop that question in the comment section so that whenever I pass there, I will see it and respond to it. Otherwise, thank you for being here. If you love this content and you really want to see it again, please do subscribe, share it with your friends, and also like and leave me a comment. Don't forget to leave me a comment there below because I'll be dropping more great videos because we're determined to sharing knowledge. We're determined to making a lot of people engineers, right? And we live in an era where sharing knowledge should not be a problem because we have all the necessary resources which can help us share that knowledge. So I intend to stop there. I think I do appreciate you. Let us meet again in the next video. Leave me a question. I'll appreciate. Thank you.